Let's have a look at the vector dot product. Suppose we've got two vectors u and v. We define u dot v as u x v x plus u y v y plus dot dot dot. So for example, if I had 1, 2, 3 as my first vector, and 4, 5, 6 as my second vector, 1, 2, 3 dot 4, 5, 6 will equal what? 1 times 4 plus 2 times 5 plus 3 times 6, right? Four plus 10 plus 18, 22 plus 10, 32. Okay, now the dot product rule says u dot v equals mag u mag v cos of the angle between them. So we can represent that pictorially. So there's u, there's v, there's the angle between them. So you can use it to get the angle between two vectors. Say cos theta equals u dot v over magnitude u magnitude v. So let's have a look at why that's true. Firstly, let's observe a couple of things about the dot product. So this first one, it just distributes. It's just the same as addition and multiplication. You've got 2 times 3 plus 5 is the same as 2 times 3 plus 2 times 5. And you can check that by, well, it's kind of obvious if you write it out. It works for each of the components. You can treat the components independently. You could do it in symbolically if you like, with A, B, C dotted with D, E, F, plus G, H, I. That's just the same as A, B, C dotted with D plus G, E plus H, F plus I. And you can see it's just kind of going to come out straight away. Similarly, if you've got alpha u times v, you could move that alpha outside. Again, it's a trivial common sense proof, just looking at what's going on. Finally, u dot u, what's going on there? That's just u x plus u y plus u z. That's just the square of the length of u, isn't it? That's Pythagoras. Yeah, if I've got a vector x, y, z, and I want to find the square of the length, that's just x squared plus y squared plus z squared. I'm using 3D examples, but this holds in n dimensions. Okay, so armed with this information about the dot product, so observe these three things. 1, 2, 3. Let's put that in a bubble. So let's start with a unit circle. And let's create our now notice, because of 2 here, we could have written this as u over the magnitude of u dotted with v over the magnitude of v equals cos theta. And that's just the unit u vector dotted with the unit v vector is cos theta. Yeah, you divide a vector by its length to get the unit vector in that direction. So this, to me, is a much tidier formulation of the dot product rule. This is what I would write in a textbook. From this, you can get that trivially. This is much prettier, and it lends itself to proof immediately, because straight away it says unit circle. We've got 2 unit vectors, so they lie on the unit circle. We've got u hat there, v hat there, and we've got theta. So let's drop a perpendicular. So what's this new vector that we've created? Let's give it a direction. So I suppose first we need to figure out this vector here. Well, it's in the direction of u hat, which I suppose I should write somewhere I have more space. What's its length? Well, we can use the cos theta is adjacent over hypotenuse. Cos theta is this length over, well, this is a unit circle, so the length is 1. So that's just cos theta, this length. So that vector is cos theta in the direction of u. Okay, so now what's this vector? Well, to get from here to here is the same as to get from here to here, and then to get from here to here. So minus that plus v hat. Now we need one more result about the dot product. We need to show that if u and v are perpendicular, then u dot v equals 0. Yeah, quick example. 1, 0 dotted with 0, 1. Those two vectors are perpendicular. There's 1, 0, there's 0, 1. You dot them together, you get 0, 0. Oops. Zero plus 0 equals 0. Okay, so looks like we should be using Pythagoras for this. So there's u, there's v, and that vector, we're going minus u plus v, okay, so by Pythagoras, this length squared is this length squared plus this length squared, but we can write a length squared using dots, so we can write minus u plus v dotted with itself, that is equal to u dot u plus v dot v. And then we could multiply this out, so we get minus u dot minus u. We're using 1 here to multiply out. Minus u dot minus u, and then minus u dot v, and then v dot minus u, and then v dot v. And that is equal to u dot u plus v dot v. Okay, minus u dot minus u is just minus 1 times u dot u, using 2. So that cancels with that. V dot v on both sides cancels. And minus u dot v is the same as v dot minus u, so we've got minus 2u dot v equals 0. Therefore, u dot v equals 0. Okay, done. So let's call that a theorem. Theorem and this is our proof. So let's box that away. Okay, so two perpendicular vectors means the dot product is 0. So here we have two perpendicular vectors. U is perpendicular to this thing, Therefore, by our theorem, u hat dotted with this thing equals 0. So let's multiply that out. So we've got u dotted with that plus u dotted with that. U dotted with minus cos theta u plus u dotted with v equals 0. So this is minus cos theta u dotted with u plus u dotted with v equals 0. So u dotted with v equals cos theta u dot u. But u dot u is just, by 3, the mag square of u. And u, it has magnitude 1, so square magnitude is 1, so we've just got cos theta done. So this was our theorem. And our proof was here. That's the dot product rule. Dot product rule. So really this should have been our lemma. A theorem is the big thing you want to prove, and a lemma is a little result that you use. So okay. What if we have a triangle where we've got u there, v here, and so this is the resultant vector, u plus v. Let's just play around with expanding out u plus v. Dotted with u plus v. Because on the one hand we know that is the mag square of u plus v. But on the other hand, we could just expand it out and get u dot u plus u dot v plus v dot u, so that's 2 lots of u dot v plus v dot v. Okay, but u dot u is just mag u squared, and that's mag v squared. So what we've actually got is that length. We could call that so let's write out what we've got. We've got mag u plus v squared equals mag u squared plus mag v squared plus 2 u dot v. Okay, I've done this a little badly. I'm trying to prove the cosine rule. The cosine rule says if you have if you're given the angle and you're given the sides A and B, then you can calculate this final side x by x squared equals a squared plus b squared minus 2ab cos theta. That's the cosine rule. And we can prove this really easily. We've practically proved it here, but I'm just going to redo the diagram. There's a minus instead of a plus that's just going to make things come out more easily. So that's our vector A, that's our vector B. So from there to there, minus A plus B. Okay, so let's expand out minus A plus B dotted with itself. On the one hand, it's equal to the mag square of minus A plus B. Otherwise known as our length x squared. And on the other hand, we can just multiply out, so we've got minus A dotted with minus A, which is the same as A dot A. Otherwise known as mag A squared. Minus A dotted with B, and B dotted with minus A, so we've got minus 2A dot B, and plus B dot B, which is B squared. Okay, done. Let's write it out in full. So we've got mag of x squared equals mag A squared plus mag B squared minus 2A dot B. And using the dot product rule that we have here, A dot B is just mag A mag B cos theta. So minus 2 mag A mag B cos theta. And that is exactly what was written there. So we can use the dot product and the dot product rule to prove the cosine rule. We can also prove the cosine rule without it, of course, but it's just nice to see that it's a very simple one-step proof. We just expand this jobby here. Okay, done.